gonna work, but we're gonna hope that this sound is working because I need to talk about notations and quadratic functions. The first one is talking about when are graphs positive and negative. Negative. Positive and negative intervals. The positive and negative intervals is in regards to x as the reference point. It's all about the x, Thank you very much. Alright, so here's the graph. I'm going to try to make it very clear to you. This graph is going to come, it's a little bird. The bird is coming down into the water. At 2 seconds, he stays down there, eat him some good fish, realize that he can't swim underwater, and he comes back out of the water. Alright, at 2 seconds he went under the water, and at 5 seconds he came above the water. I'll repeat that. Thank you. At 2 seconds he went under the water, at 5 seconds he came above the water. When was the dolphin positive? Well, the bird that's going down to think he can eat a dolphin. To 2, but what? When did it start? All the way over here. What's this direction? He's coming from negative infinity all the way to 2 seconds. Is that a hard stop or a soft stop on 2? It's a soft stop. Is he gonna stop? Is he gonna stop flying at 2? Does the time end at 2? So it's a soft stop, which means it's a parenthesis. He was also positive at 5 seconds. So soft stop, 5 seconds, all the way to his life ended. Yeah. Well, he may be still living. That's why he's going to infinity. Because drama is theater, and I am theater, therefore I am drama. Alright. The little seagull, pelican, thought he was a dolphin. He went under the water. When did he go under the water? At 2, parenthesis 2, comma, 5, with the parenthesis. So, positive and negative intervals, the reference point is the x. Think about the little seagull or the dolphin swimming. The next thing we need to talk about on our handy dandy notations are increasing and decreasing. Okay, reference point, x. Little birdie dove into the water, and then little birdie came out of the water. At what point is he increasing? 5 to what? 5 to infinity. 5 to positive infinity, he is increasing. Little birdie got hungry. He was decreasing from way over here before we even met him. To 2? No, to... It's probably 4 or 4.5. We'll say approximately 4. Negative infinity, approximately 4. Let me zoom in. Erase this. Negative infinity to approximately 4 seconds. So squiggly for approximately. Now, today we're going to talk about the average rate of change. So how did how was his speed coming out of the water? Like, how did his speed change from 4 seconds to 7 seconds? That's the average rate of change. Was he traveling in a forward direction, or was he traveling in a negative direction? Those are the types of things that we're going to talk about today. But are there any questions on these notations? All right, if there are no questions on the notations, I'm going to hit you with a third one. The third notation is the average rate of change. Average, so AVG, rate of change. Up like this. All right, average rate of change is also with the reference point of x. Average rate of change is with the reference point of x. So, it is going to be written with x and x. So, if they ask you what's the average rate of change from 0 to 3, that is along the x-axis. From here to there. I want to make sure we're clear on the notation. When we get ready to study average rate of change, the notation is x to x. Because when we're doing average rate of change, it's more like a calculus concept. The reason we have to look at it between an interval is because it's finite. So we put it goes on and on in both directions. So we put them in brackets for the average rate of change to say, hey, we're studying just this part. We are definitely looking from 0 to 3. So you're kind of just pretending that that's all that exists. Good question. All right, we're going to move on to average rate of change. Wait till I finish teaching, please.